Hi there. In our last section, you learned about the different type of sequences. In this section, you are going to learn about arithmetic progression, how to find the nth term of arithmetic sequence, and properties of arithmetic sequences or progressions. So let's begin. Arithmetic progression. In order to define the arithmetic progression, what I'm going to do, I'm going to consider a sequence and then we will define a pattern for that sequence. Thereafter, we will talk about how the arithmetic sequences are derived. So let's consider an example. So my sequence is 55, 65, 75, 85, and this sequence keeps going. If you look closely between these two numbers, the difference is 10. So basically what I'm doing, I'm adding 10 with 55 to get 65. The difference between 65 and 75 is also 10. So technically I'm adding 10 on 65 to get 75. In the same way, between 75 and 85, I'm adding 10 to get 85 out of 75. If I have to guess what number will be over here, what can I do? I can just add 10 with 85. So if I add 10 with 85, the number over here should be 95. So as you can see, the difference between any two number is 10. So technically, I can call that difference as a common difference. Now let's consider another example. So this is my another sequence that I have where the first term is 50, negative 50, negative 150, negative 250, and negative 350. Let's talk about first two numbers. So between these two terms, the difference is negative 100 because negative 50 minus 50 is negative 100. In the same way, difference between these two numbers is negative 100. Difference between negative 150 and negative 250 is again negative 100. And in the same way, the difference between negative 250 and negative 350 is also 100. So if I have to guess what number I should put after 350, what will I do? I will just find the difference between this number by 100, and if I do that, I will get 350 minus 100, which is 450. So the number after 350 will be negative 450. So if you look at this sequence, you can see the difference between any two number, or I should say the difference between any two consecutive number is negative 100. So I can call that difference as a common difference. So if we create any sequence which looks like this, or in other words, we can say that if I create a sequence where the difference between any two consecutive number is same throughout the sequence, then that type of sequence is called arithmetic sequence. Now let's define the arithmetic sequence mathematically. So a sequence A1, A2, A3 dash dash all the way to An is called arithmetic sequence if An is equal to An minus 1 plus D, where An is the nth term and D is the common difference. This D is the same common difference that we were talking about in the last slide, where we had the difference of 10 for the first sequence that we considered, and the difference in the second sequence was negative 100. So this is the same common difference we are talking about. So what I'm going to do, I'm going to create a general rule to find the nth term of the arithmetic sequence. So let's consider sequence A plus D, A plus 2D, A plus 3D, and it keeps going. Where you can see this is my first term, this is my second term, this is my third term, and this is my fourth term. In the same way, I have my nth term somewhere over here. If you look closely at this sequence, you can see the difference between any two consecutive term is D, no matter which two term you consider. Now, what I'm going to do, I'm going to rewrite this A as A plus 1 minus 1 times D, because 1 minus 1 is 0, so 0 times D is 0. So A plus 0 is A, so basically there is no difference if I write the first term like this. In the same way, I can write the second term as A plus 2 minus 1 into D, because 2 minus 1 is 1, so 1 times D is D, so A plus D, exactly the same. In the same way, I can keep doing. And if I keep doing, my nth term should be A plus n minus 1 times D. So this is my first term, this is my second term, this is my third term, this is my fourth term, and this would be my nth term. So basically, how do I denote my first term? First term is A1, my second term is A2, my third term is A3, my fourth term is A4, and my nth term is An. And if you remember, at the top, we started with A1, A2, A3 all the way to AN. And basically, these A1, A2, A3, A4, dash dash AN are same, just like that. So what is my nth term? My nth term is AN is equal to A plus N minus 1 times D. So I can write my nth term as AN equals to A plus N minus 1 times D. And this is my nth term of the sequence, where N is 1, 2, 3, 4, 5, 6. Keeps going. Basically, we decide what number will be put for n depending on what term we are going to consider. Now let's talk about some properties of the arithmetic progression. Property 1. If a constant is added, subtracted or multiplied to each term of an AP, then the resulting sequence is also an AP. It technically means that it does not matter whether we add, subtract or multiply a constant with all the elements of the sequence is still the arithmetic progression. Property 2. If each term of AP is divided by a non-zero constant, then the resulting sequence is also an AP.